Welcome to Center of Math's Unusual Properties in Math. So today we're going to give two examples, one of a divergent sequence and another of two sequences that have some special properties about them. So first an example of a divergent sequence n, for which the limit as n goes to infinity of a n plus b minus a n equals 0 for any positive integer p. So as n goes to infinity, p will, and we take p terms later in our sequence, so we take a n plus b and compare it to a n. So a n plus b and a n get as close as we want if we select a given integer p as we go forward in the sequence. So one example of this is if we take a n equals partial sums of the harmonic series. So a n equals 1 plus 1/2 plus 1/3 plus 1 over n. First we can note that this in fact does diverge, since if you look at 1 plus 1/2 plus 1/3 plus 1/4, etc., we're just going to do a kind of Cauchy condensation. So we're going to take 1/3, we're going to say this is greater than if we send 1/3 to 1/4, 1/5 to 1/8, 1/6 to 1/8, 1/7 to 1/8, 1/8 to 1/8, and we're going to continue in this manner. And we know this is greater than 1 plus 1/2 plus 1/4 plus 1/4 plus 1/8 4 times. But note, so every time we reach a power of 2 and we set the terms before it or after the previous power of 2 equal to that 1 over that power of 2, we'll have 2 to the n minus 1, 1 over 2 to the n terms, which is 1/2. So this is greater than 1 plus 1/2 plus 1/2 plus 1/2 plus 1/2, an infinite amount of 1/2s. And so it's greater than something that diverges, and so it itself must diverge. And note a n plus b minus a n equals 1 over a n plus 1, 1 over n plus 2, plus 1 over n plus p. And this is less than p over 1 plus n plus 1, because 1 over n plus 1 is the greatest term in this series. And since p is a set integer, n can get as big as we want, this fraction will go to 0 as n goes to infinity. So two sequences, a n, b n, such that infinite limit a n plus infinitum limit b n is less than infinite limit a n plus b n, less than infinite limit a n plus supremum limit b n, plus, and this is less than the supremum limit a n plus b n, which is less than the upper two limits of upper limit a n plus upper limit b n. So you can show that these inequalities aren't necessarily strict, they can all equal each other, but we're going to give one example such that none of them are equal to any of the others. So take the sequence a n to be 0, 1, 2, 1, and then repeat those 4 digits. Take b n to be 2, 1, 1, 0, repeat those 4 digits. So a n plus b n is then 2, 2, 3, 1, and those are repeated. So the lower limit of a n is the lower integer here, which is 0. Same for bn. The upper limit is the same for a and bn, 2 and 2. Upper limit of a n plus bn is 3. Lower limit is 1. That's 1 is the lowest integer, 3 is the highest integer. So the lower limits of these two is 0, so 0 plus 0 is 0, so this is 0. A n plus bn, lower limit is 1, so this is 1. Lower limit of a n is 0. Upper limit of bn is 2, so this is 2. Upper limit of a n plus bn is 3. And then upper limit of a n plus upper limit of bn is 2 plus 2, which is 4. So when we do out each of these numbers, we see this inequality is saying 0 is less than 1, less than 2, less than 3, less than 4, which shows that it's possible to have these all unequal to each other. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. And if you like this Unusual Properties in Math video, please check out our other videos in our playlist. Thank you.